Hello, ladies and gentlemen. Welcome back to some more While True Learn. And I'm excited to jump back into this. So let's just do it. We were last trying to set up a self-driving car startup with a good mechanism for discovering red and green, circles. And we designed a slow system that worked. And if I remember it right, it took about 19 seconds on average for everything to reach its destination. And part of the reason for that, if we test run here, is that, well, this SIFT system is very slow. We're actually doing this very slowest thing first. I mean, which is fine, I guess, but I prefer to do the slow stuff at the very end so that we can process as much as we can so that the slow stuff actually has to operate on less data. So for example, if we filtered out the blue things and didn't have to ask whether those were circles or not, this whole thing would be faster. So 19 seconds is our personal best thus far. We want to make this a little bit faster. And of course, there are load balancers and stuff we can throw into the mix, but there's additional server costs associated with using those. So let's see what we can do initially by just starting to reorder things in terms of their speed. So first, I guess the decision tree color, it's not really going to filter anything out for us, but it does let us sort of get some free parallelism anyway. Because we're splitting off red and green, and of course blue will equally go through here, which means that we can use two separate expert systems without having to pay for another server to filter out the blues. I'm just gonna let's clear this out because yeah, these lines are gonna be a pain to drag. So we need to filter out a couple of things. We need to filter out everything that's not a circle. We need to filter out everything that's blue, and then we need to sort by red and green. But if we do that in reverse order, this only takes 0.275 seconds to do its initial sorting, so better, right? So we do our split first. Then we will filter out everything that is blue. And actually, we don't need to use expert systems here, do we? No, we don't. We can use decision trees again to find everything that is blue. Perfect. And everything that is red is great. Everything that is blue versus everything that is green. So we're ignoring the shapes entirely here. And then at the very end of things, we can finally sift out, hey, by the way, I only care if it's a circle. Right, so red is the happy path here. And then great. And then we've got a whole bunch of trash that we need to wire up. But we'll use two sifters, and we're not paying additional costs here now. Green here is the happy path. And I've got all these happy paths correct. Yes, okay. So, trash cans. If it's not a circle, it's trash. If it's not green, it's trash. Of course, we could just wire these all up to the same trash can, but hey, I'm feeling lazy. And then, of course, if it's not, we have one more trash up here. It's not a circle for that one. So rather than doing any load balancing at all, we've kind of optimized this on our own. In theory, let's test this and see what our average destination time ends up being after the thing processes a little bit. Okay, so that feels significantly worse. I've managed to make that terrible. I think the reason that this average is going up is, well, because we're sending through a lot of we're not discarding the bad data as quickly as we could. At least when we were sifting out everything that wasn't a circle, we were discarding 2/3 of things right at the very beginning. And if we could see that things were really backed up here, coming out of the decision tree, looking to sift just those shapes. We're really only culling out 1/3 of things there. I want to see if maybe we can just throw some load balancers in at this point. Let's just toss that here, and yeah, we can throw in some load balancers here in front of two sifters maybe, and see if we can ease that up a little bit. Oops, drag from here to there, and we'll add additional sifters, because the sifters are admittedly quite slow, but yeah, that's fine. Okay, so else, trash, good. That, we need a load balancer here. And I could be thinking about this all wrong. It could be that we're doing better filtering things out on a different standpoint. We'll have to kind of see how this goes. Let's look. Let's see where we back up now. So now the sifters are getting information. I think it is going to throw more data at us as it discovers we can handle the load. So we're going to see kind of how long this takes. Our average destination time is worse than what it was before. So our time to beat, well, we haven't managed to beat it. That's kind of disappointing. And this is getting to be sort of complicated already, and we're spending a fair amount of money just to do it. Oh, whoops. Ha. Yeah, I have this thing wrong. I didn't have that hooked up. Let's try that again. Whoop, test. So I'm curious, if we let this continue to run, what's going to be the first thing that actually backs up? Because I think it is going to start feeding us data faster and faster the longer we continue to test, hopefully. And then we can see what ends up being the crazy slow part, right? So I think this is pretty stably telling us that we're managing 23 seconds at a pretty significant cost and around 90 users a day, 87. I'm not entirely sure where that's coming from because it really seems based on how fast we're injecting stuff through the system, and we haven't stalled out on any of these yet. But this isn't faster than the original system we had, so let's take a look at that original system and see maybe are we doing something a little stupid. I'm actually wondering, since we're splitting out into 4 different sifts, if it maybe does make sense to actually have that on the front end, because 4 pieces of data getting through here in 1.14 seconds, well, that makes the time competitive with the decision tree. So let's go back to our original plan. Okay, so what did we have? We had this in the stupid order. We had something like an expert system and an expert system, which we shouldn't even need to be using at all. An expert system, which discarded blues. We discarded circles. We kept circles and discarded everything that wasn't circles. We discarded everything that wasn't blue, and then we did our actual split. Blue went to trash can. Boop. And everything not blue went to here, and then we did our split, and this got rid of the data a heck of a lot faster, although I think our users per day was a heck of a lot less. I mean, this is one area where I think it is actually difficult to tell what the right thing is, because the amount that it's throwing at us doesn't seem to be, it seems to be different. We're processing stuff at a reasonable-ish rate. Well, maybe it's throwing a stuff based on when it thinks we're getting stuff out of the first system. Maybe, I don't know. Well, okay, let's look at some minor optimizations that we can do here. Even if we can get rid of the expert system and use a decision tree at the front without really any penalty, and then just filter out blues with more decision trees. We've done that plenty of times. This is red or blue, and this is green or blue. And well, let's reverse these just to keep this a little clean. So green can go here. This goes into this decision tree. Blue goes to trash. Blue goes to trash. Red goes through. This goes to here. That's a little bit fast. It should be at least a little bit faster. Should have better throughput. Should have do a little bit better. 2 users a day, 18.4 seconds. Our destination time is getting faster, so that's great, I'm guessing. And honestly, I think this is probably the right path to be going. Now, do we get our custom nodes here at all? I'm just curious. Do we get to use? Oh, we do. Cool. Let's see. So I actually don't need to worry about doing the load balancer myself. We could do 0.04 seconds. That's what the load balancer is anyway. Although actually, if we do want to do 4 parallel things, using this saves us a little bit of time, because we don't have the transfer from load balancer to other load balancers. So that's, I guess, the benefit of having some of these modules. Wait, what is WBWG divide? Oh man, I don't remember. Only red parallel, 4 parallel, blah blah blah. This is 6 servers, which gets expensive. But if we just use a single load balancer and do this whole sifting stuff, I wonder if that's the right route. So we'll just have another sifter at the top here. Sure. I don't like the way that these lines cross, but that's okay. That goes into there, and then we're rejoining this stuff back up. So let's see if this is. Oh, this seems to at least it thinks it can go faster, so it's throwing more stuff here. The load balance. Okay, now we're backing up. Now we're definitely backing up a fair bit, and it's letting us know, hey, things are getting stuck. Things are getting stuck in the queue. That's what's actually making this time go up. Okay, fair enough. So stuff is stuck here at the load balancer, and whatever. So okay, let's yield to crazy parallelism. We'll throw in our 4 parallel thing. And I still don't know if this is the right approach, honestly. I don't know if it's better for us to, it might be better for us to sift things at the end, but we are we're getting rid of so much information early on by sifting out the shapes. We're getting rid of 2/3 of the data, so everything else in theory can be so much faster. But does that end up mattering? Who knows? All right, well, 1.1 seconds divided by 4 gets us in the realm of these decision trees, so we're roughly performing, I guess, about the same. I'm just going to reuse these trash cans, and these lines are going to look all sorts of messy and garbagey. Shame on me. Shame on me for not being cleanly. All right. That is a terrible chain of things. Let's test it. And, of course, we're spending $12 a second to do this. Where are we backing up? We are backing up on these sifters. And, of course, this destination time just continues to creep up. Blech. Yeah, okay, so I think I gotta call it, I gotta say no on this whole system of trying to filter everything out slowly, but initially. I'm still not entirely sure what is guiding how much information goes into our system. I think it's gotta be based on whatever this first thing is. It says, hey, oh, you can process things at 0.046 seconds, so I'm gonna start feeding you one piece of data that frequently, and then of course we end up with these backups because it's trying to throw all of this stuff out here. We end up with this long, crazy chain. I'm not sure. I wish this game was a little more explicit about that, but that's okay. I guess we will just, can I do, oh, I can do that. Nice. Oh, no, get rid of them. Oh, okay, I guess I gotta get rid of them individually. Well, that's fine. I can at least go back to, if we do this, we split on color initially, we filter out the blues, and then at the very end, we throw these sifters on. And hey, we're not paying additional costs that way, and we end up with something that's reasonably fast, or at least competitive with our other solutions. So, I mean, that's got to be the best we can hope for, right? Let's go ahead and test this one out. Now, of course, it is. I guess it's feeding us now stuff every 2.275 seconds. We are backing up at the sifters again, but we're getting information through at some sort of rate. No, okay, now we're creeping up again. I guess we just add the additional load balancers, right? On the sifters themselves. So we do this, and load balance 2 sifters, load balance 2 sifters. I wonder if there's a way to copy paste stuff here. Man, this game is challenging. I don't know why I'm so bad at it. I should do this in a little bit of a cleaner way, but whatever. This is fine. All right, this goes into here instead. This goes there. This goes there. And circles and trash. Okay, so we're paying $8 now for data. We're getting stuff through at 22.6. Nothing seems to be backing up. These sifters seem to be managing the amount of data that they're getting. So let's call that good, I guess. At least I don't know well enough to come up with a better optimization. So let's call that let's call that as good as we're gonna get for now. And we can come back and try to optimize it a bit more later, I guess. Yeah, the interesting thing is because when we have things going the input straight into a sifter, it feeds us data more slowly, which means that our users per day, I guess, is slower. Aha! Oh, so that must make sense. So the users per day has got to be based on whatever this first node is, which is 0.275 seconds, which I guess we could be faster with a load balancer, but whatever. And do we have a... Do we have a... Let's see, ooh, without blue. Ooh, without blue. This felt a little bit, but that's not faster than anything we've got. Only red, fast, only triangle, fast, all green, divide, 2 parallel, 4 parallel, only red, parallel, only red, WB, WG, blue and green divide. All right, so there's nothing I don't think that we can take particular advantage of. Okay, so the users per day has got to be based on how fast this very first node is able to take in data, and then the throughput is kind of given that, how long is it taking for information to get through the system, whether to the trash or to something else. And yeah, okay, if we put this trash can in the middle there, it's a little bit cleaner, I guess. All right, well, whatever. We've spent a long enough time on this. Let's go ahead and deploy that one out. And we'll see what happens. Current users 86. Our shares are worth less than we paid for, so I have no idea how this is going to go. But okay, let's jump into an actual task now. From the National Heritage Protective System. Good morning. We have dozens of scientific equipment in protected areas made to look over the object of national heritage. We receive info from our equipment on a daily basis and need to sort it depending on the color of the report. We need to make it work better and react faster. Can you make a program that will help us? Well, if prior experience is to be our judge, who knows? Oh, okay. This is just splitting on color. Cool. Only red fast, all green divide. Hey, we've got an all in green divide. That's nice. All, all in green divide? No. What is that? What is that gonna do? I don't know what's gonna happen there. I guess only red is gonna get rid of everything else. But if all is, so is this all meaning everything else, or is, no, it's not else, it's all, okay. Because we have other things that are else. Fair enough, okay, whatever. What are we talking about? Decision trees, decision trees, decision trees. Let's split on something and then split on something else. So if it's red, if it's green, and then blue is gonna go to both of these things, or sorry, if it's, let's see, red if it's blue, cool. And then green is gonna end up going to both of these, because green will be wrong for both of these answers, so it'll get evenly split. So then we'll split on green here. It's blue, and this will be green. And I'm wondering if this is going to be performed enough. It needs to be accurate, so that's fine. Yeah, let's check. Okay, yeah, that's fine. We spent too much time doing these load balancing parallel things that I got myself overly confused. That works. Yes, go. Okay, $24 in cat clown expenses. I like this one. I actually want to check now. How did our startup do? Let's look. Current users 185, week income negative $92, but no overload. So who knows? Maybe as the users increase, we'll be okay. But yeah, we're not making money, so maybe we shouldn't have parallelized at all, and should have accepted just fewer users at a time. I don't know. Well, we'll go back to it if we need to. Forecasting the amount of sales in the clothing store. Hi, I have a clothing store and want to know how much money I may get during holiday sales. Help me. Sure. This is what we just did, isn't it? Didn't we just do this? RGB sort. Yeah, we already have this. RGB sort. Red, green, blue sort. Test. No. Low accuracy. Not enough time. Okay. We need to do that faster. Okay, fair enough. Do another RGB sort then. I wonder if there is, I've been looking around to see if there's some sort of button I can hold down, some sort of modifier key that lets me kind of duplicate a thing, just sort of, you know, like if I held shift and dragged it to create just a copy of the same thing, but haven't come across one of yet. We will see. All right, let's see if that works. There we go, much better. I mean, more expensive, but better. And hooray for money. And Cool. Okay, good morning. We are a scientific laboratory that researches human behavior. We need to extract the data of our last research from our equipment across the city. This is some important information, so please be very accurate. All right, we need to be 50% accurate and get things done in 15 seconds. Accept the job. Okay, so no blue. We do get to use, RGB sort. Nice. Is this enough? Can we just RGB sort ourselves, but with the trash? Oh, we don't get a trash. We don't get trash. Oh. What are we supposed to do then? I mean, can we just let this back up? I don't know, maybe. There are only 6 blues, so maybe we just don't care. We just don't care. Yeah, I didn't hook this output up to anything, but it's got enough of a buffer for bad data that we're fine. Fair enough. I mean, that's probably going to come back to bite us if we ever try and reuse this scheme somewhere, because it'll get blocked, but hey, we can clean that up some other time. It's weird how you don't get trash in some of these cases. Oh boy, our weak income has gotten worse for the self-driving car. Let's look at that real quick. Oh yeah, we're overloaded and we're not making money. This is this is not great. We're making money on the first startup though. Oh man, what are we supposed to do here? We're too expensive for not getting enough data through. I don't know. I don't know. I don't know how to what we should be doing to make this faster. All right, well, whatever. We'll hope it gets somehow magically better. Client's solvency assessment. I mean, I suppose if we get a lot more users, then we can justify more load balancers. Ooh, private. Mail from a friend. Hey, what's up, buddy? How are you? Listen, I remember that I could not pay you for a long time. I'm very grateful that you did not demand it for so long, but to be in debt to even a friend is not cool. Therefore, take this money. I return everything that I owe you. Thank you, friend. You really helped me out. Yeah, and how about we go to a concert next week? Thanks from BFF at Cat Me Out. Sure, I will take the cash. That sounds great. Oh, another startup. Sounds like a great time to get out of this investment, honestly. Can I leave? No? I don't know. Well, let's do one more challenge. I think we'll jump back on this in a future episode. Client's solvency assessment. Good afternoon. It's Moneybag Bank. We want you to create a system for sorting candidates for receiving credits in order to reduce the number of errors. Okay. We would be happy if you complete the task before the holidays. So would I. All right. Which holidays are we talking about? All right. Same thing here. We've got 10 blues. 27 seconds. We need to get a lot of greens through this system. Green, and then red. Do we have to filter out? We do have to filter out, because we'll end up with, on average, 5 blues going this way, and that's going to reduce us below that accuracy. But if we slow down this chain and don't slow down this chain, we can end up with some bad blues over here without causing problems. Yeah, and in fact, we need to, because it's expecting 41 pieces of data, and we only have 40 greens. So cool, we'll just filter, we'll do good filtering here. And I wonder if we can just let this back up too. How much do we have? Yeah, Saki-Q says we can have 13 pieces of data backed up that back up in this thing without connecting it up to trash. And we're only expecting to get about 5 coming down this way. So let's test it out. Perfect. All right. So this is weird because we don't have the trash for whatever reason, but it works. Let's go ahead and release it. Alrighty, and we'll go ahead and stop there. We're making money on our individual projects, but not doing so great on our startups at the moment. In fact, it looks like even the first startup has gone a little garbagey. So that's a shame. We're gonna have to see what we can do about selling off our shares, because we just don't seem to be performing well enough to justify the continued investment. But anyway, I hope this has been entertaining for you, and I will see you in a future video. I will talk to you then. Cheers.